equals vi squared. I've got L, oh, yeah, that's right, L minus D. Vi in this case is how fast it's going at that point. It becomes a projectile motion problem. In other words, at point B. So L minus D G sine theta plus 2 times negative G times, what was our displacement? Negative L minus D sine theta. I plugged in the vertical stuff here, so this is going to be my vertical component. So I get LG sine theta minus GD sine theta plus, those two minus signs cancel out. So plus 2GL sine theta minus 2GD sine theta. Let's see, I got an LG and an LG there. A marker that sucks. So I have 3GL sine theta minus 3GL, sorry, GD. Sine theta is my final speed squared. So that's the speed, that's the vertical, the vertical component of the speed just before it hits the bar. I know, let's see, I can factor out 3G sine theta, and I'm left with L minus D there. I know L is bigger than D, all of these are positive numbers, but I know that it's heading downwards at that point, and so my final vertical velocity, over here, final vertical velocity is going to be negative 3G sine theta L minus D.
Wouldn't it need to be the square root of that? Because you have it for B squared.
But the negative's on the outside of the radical.
Does it matter if that's the speed and that's the velocity?
That's why the negative's there to take that into account. This does only tell us speed, but I know that at this point it's heading, the vertical component is downwards, and so therefore I know, since I said up was positive, it's got to be negative. Okay, now what?
We also have to find it for the I-hat.
Fine for, well, I had the acceleration is 0, so it's going to be the same.
This, yeah. Okay.
We usually have to find time for JF.
Okay. So the time, what equation should we use?
VF equals VR plus A times T.
So that's negative square root of 3G sine theta L minus D equals, that is, should be what I just wrote down. Oh. No, that is, okay. Equals the square root of L minus D G sine theta cosine theta minus GT. And so we end up with T, let's see, bring that over to this side and that to that side, so GT equals the square root of L minus D G sine theta cosine theta plus the square root of 3g sine theta L minus d. And then we can just divide by g. Well, that's a fun expression right there. I just did a quick unit check just to make sure it still makes sense, and units are still working out okay. Now what? I mean, ultimately, we want only L's and D's and any constant showing up in the final. This has theta in it, which is, we could, I mean, I know what sine of theta is equal to. From that, I can figure out cosine of theta. But we do have one other relationship here that we haven't exploited yet, and that is, I know the horizontal displacement, and I know the initial velocity, final velocity, acceleration, and I now know time. So I have another relationship there using the horizontal information. So let's go ahead and do that. Using delta S equals VIT plus 1/2 AT squared. Except for the horizontal, that is 0. My displacement is L minus D cosine theta, and I'm going to flip back just to make sure that, yep, is equal to L minus D, lost it already, L minus D G sine theta, L minus D G sine theta, cosine theta, times time, which we now have an expression down there, square root of L minus D G sine theta cosine theta plus the square root of 3G sine theta L minus D over G. It's as simple as that. And as you would expect, it's going to come out to something very simple. All right, it's a lot of writing there. So what I'm going to do is I'm going to do a shortcut. I'm just going to let S equal sine theta, C equal cosine theta. So I don't have to write as much. I know that S is equal to 2D over 3L minus D. If I know sine, how do I find cosine?
Could you get a derivative of it?
Non-calculus based.
Pythagorean theorem.
Yeah, in essence. I know that sine squared plus cosine squared equals 1. So cosine is equal to square root of 1 minus sine squared. Theta, again, is this angle right here, so it is a first quadrant angle. Sine and cosine are both positive, so I don't have to worry about that mess. So this would be equal to the square root of 1 minus 2D over 3L minus D squared. And now we just plug into here, simplify. I hope we haven't made a mistake somewhere. I'm encouraged that one mistake was already pointed out. I'd like to think enough people are vigilant. And I'm gonna need a lot of room, running room here. So any questions about what I have up on the board before I erase? Well, erase that. I'm gonna go ahead and distribute, since I so I have L cosine. And cosine is L times the square root of 1 minus 4d squared over 9 L minus d squared. Minus d times the square root of 1 minus 4d squared over 9 L minus d squared. Wow, this is gonna be a mess. Equals square root L minus d G 2d over L minus 3 L minus d times the cosine of theta, which is 1 over 1 minus 4d squared over 9 L minus d squared. Gets me to there times square root L minus d G sine theta. Oh, wait a second. Well, let's simplify it before I'm gonna erase some of this. I have a square root of g here, I have a square root of g here. Well, I can factor out a square root of g out of those. I have a square root of g here, so that's gonna cancel out with that g, so all the g's on the right-hand side go away. Times. Well, that's just the same thing I have right here. So times that plus square root of 3 sine of theta, which is 2d over 3 L minus d. I did make a mistake over there. So I've got this equation with a bunch of radicals in it. How do you deal with that?
In the equation, can we put squared after like the first, where you have the equal sign, where you didn't write it twice, can we do squared? So,
Oh, just square, well, I have to distribute it, so I was trying to think of the simplest way of doing that. Yeah, when we distribute, it'll be this squared plus this times that. So, actually, now that I've broken it apart, I'm thinking keeping it together for a moment. Square root of 1 minus 4d squared over 9 L minus D squared equals L minus D, 2D over 3 L minus D, 1 minus 4 D squared over 9 L minus D squared, plus the square root of L minus D. Oh, that cancels out with that. So up with 2 D over 3 times 1 minus 4 D squared over 9 L minus D squared times 3, well, those 3's would cancel out, 2D L minus D. I will say it will be a miracle if we come out with the right answer. Well, I have it in terms of L and D now. That's L minus D right there. So how do you solve it when you have radicals in the problem? How can we get rid of the radical? It'll take 2 steps, unless there's a way I'm not seeing right now. Notice I do have something common here. When you're faced with this problem, I've got I have 3 terms. Is there a common factor? Almost, yeah. There's another one that's a little bit better than that.
The square root of 1 minus 4D squared over 9.
So if I divide everything by that, that goes away. That one goes away. And here, I end up with 1 minus 4D squared over 9 L minus D squared square root. That goes away. Oh, no, sorry. Wrong. Square root of that. So if I divide by the square root of it, then I'm left with the square root right there. That'd be like if I have x squared over x, I'm left with just x. That's where that comes from. I have now only. No, I still have 2 radicals in there. That L minus D cancels out with that L minus D. So I'm now down to L minus D equals 2D over 3 square root of 1 minus 4D squared over 9, 1 minus D squared, plus the square root of 4D squared over 3L minus D. We need to isolate the radical, square both sides to get rid of it. We'll have a radical left over, then we need to isolate that one, square it. In for a penny, in for a pound. All right, you pumped to land this? Woo! I will say that the other times I've done this, came out simpler. Than this, I'm not quite sure where, I mean, there are many paths to get there, so. we'll
Was it
see.
my final velocity equation?
That's the part that I don't usually do.
I apologize.
Good question.
Yeah.
So we were at the initial velocity, right? And why is the initial speed 0? Or is that from the bird, like?
There's basically, the initial speed of the problem here is at point A is 0. But then at point B, which is the final speed of our conservation of, well, final speed of sort of the pendulum motion and the beginning initial speed of the projectile motion. And I put A and B there so I could use those as subscripts and then consequently didn't. Okay. Question answered? Okay. Other questions? Minus 2d over 3 square root of 1 minus 4d squared over 9l minus d equals the square root of 4d squared over 3l minus d. Square both sides. We'll get rid of one of the radicals. So we end up with L minus, let's see if I can have a color that actually shows up here. L minus D squared minus 2 times L minus D, 2D over 3 square root of 1 minus 4D squared over 9L minus D equals 4D squared over 3L minus D. So basically square both sides, plus 4D squared over 9 times 1 minus 4D squared. That's tacked onto the left-hand side. This, what I did over there, A plus B, or I guess A minus B squared is A squared minus 2AB plus B squared. That's where that comes from.